Let us solve the exercise number 5 in the part A of operating system lab. In this exercise, we are supposed to accept a number n and check whether the number is prime or not. So I am starting the virtual box here, and I have already taken the liberty of starting my virtual machine. I will switch on to the virtual machine over here, and let me log on to the my machine, and I have given the description of the password and the details of how to log in the previous video. So if you have not watched that, please watch that video. It will be available in the description section. So this is what I have it here, and I'm going to go and I'm going to click on the start over here. You can search for the Notepad++ here, and under your operating system, you can just type for Notepad, and you get an editor for the source code editor. This is also available in your desktop over here. You can double click on it and just start the notepad. Let me just zoom out for you. So the notepad will start. Let me close the previous exercise and let us start the new exercise. You can create the new exercise by clicking on the file and the new. So it is simple as that. And what we are supposed to do is we are supposed to accept a number, and then we are supposed to check whether it is a prime or not. The first thing you are going to do is you save the file. The reason why you have to save the file is when you save the file with the proper extension, there will be a code highlighting. Suppose if you don't want to save it, then go down and you have to select the type of the file that you are creating. Now I'm going to go to the yes here, and under this yes, you have to select what is that you are going to do it, whether it is you are writing a shell script and so on and so forth. So you have to select the proper type over here. Now, instead of wasting your time in selecting whether you are going to type a bash script or not, you can save it with the .sh. But if you don't want to save it, then go here. By default, it will assume that you are writing a text file, but you can always go here and then say bash. Then onwards, it will start the syntax highlighting. Now, my personal advice is just to save it at proper location. So where am I going to save it? Now, if I go to my computer, and within my computer, I will select my documents over here, and under my document I have already created a folder for VCA. If you are not created, right click and then say create a folder, give a proper name. I'm going to save it under VCA folder, wherein I already have the previous exercise that is being saved over here. So I'm going to go here and I'm going to click on the file save, or you can also use file save as. So both are same. I'm going to just save it because you are saving it for the first time. I'm going to click on save, file save, and I'm going to go to the my folder over here. That is the name where I have logged in, and I'm going to click on it. You can double click on it, or you can click and then select open here. Both are same. So I'm going to open the documents. Under documents, I have my folder. So I've given the name as BCA. You can double click on it or click and open, one and the same. So I'm there at my login and then my documents, and there under the my documents I have it one more folder called as VCA, and I'm going to give a proper name to this one. So I'm going to call it as exercise A5, but remember you have to put the extension as .sh. So that is very much required, because then only it will highlight the scripting. So you do that thing and then click on the save button, and that's it. You have it there, and you notice that by default it will select bash here. Now let us start writing the code, and what they have said in their code is, let me just go back to the Windows and then just show you. We are supposed to accept the n here, so let me go here and then let me write it. So if you want to increase or zoom in or zoom out, hold the control and use the mouse wheel to increase the size of it. Let me write the read here. So I'm going to read and I'm going to use the minus p, and I'm going to say enter a number. So enter a number. This is what I'm going to say, and put one space in that, then followed by this number n. This is what they have said. We are supposed to accept the n. So I have accepted the n, and I am supposed to check whether it is a prime or not. You know very well you are going to check the prime number only if it is greater than 2 or not. So you don't even check whether if you say the given number is 1, it is not a prime number. Negative numbers are not considered as a prime number. So the first thing I'm going to go over here and do is I'm going to check if the number that is given to me, if it is so what is this number? So the number that is given to me, if it is less than 2, that means to say that anything that is less than 2 is by default is not a prime number. Then I'm going to say that echo it is not a prime number. So you can say $n is not a prime number. You can say that, and then you can just exit this one. So exit with the 0, saying that the code has ended, and because you started with the if, you have to close it with the fi. So this is what you're going to do it. I'm going to just save it. And how do you run this part of the code? So you go to my document and double click on the my document, double click on your folder, and don't double click on the this one. Okay, so after this, when you can see your the file over here, just go to the tools and select open terminal here. You can press F4 from your keyboard, or just click on open terminal. The terminal will open here, and within the terminal you have to give the proper name. And for your kind information, the Unix or the Linux is case sensitive. So what you type in capital is not same as small case. So I will run a bash script. So I will say bash followed by the shell that I'm going to use is bash followed by the exercise ex. So remember, these are case sensitive. So if you type it in small case and capitals, they make a lot of difference. So it is exaf5.sh. I press enter, and it is going to accept one number. So I'm going to type -5, and I must get -5 is not a prime number. Suppose if you want to run it again, use the up arrow key. You don't have to type it again and again. You can use the up and down arrow key from your keyboard and get the thing. So suppose if I say 1, 1 by default is not a prime number. If you have confusion whether 1 is prime number or not, just Google it and say, ask the question whether 1 is prime number or not, and you will get the explanation why that answer Google is giving. Okay, and that is true for your kind information. Let us now check whether the given number is prime or not. How do we check whether the given number is prime or not? So this is the easy step. Let's go for the toughest challenge. What is the toughest challenge that we have? So toughest challenge is if you want to check whether the given number 5 is prime or not, you will have to constantly divide this one by different numbers. So you start dividing 5 by 1. 1 will divide every number, so you don't check with that. So you check whether 2 is dividing 5. If 2 is not dividing 5, well and good, then check whether 3 is dividing 5. If 3 is not dividing 5, check 4 is dividing 5. If 4 is not dividing 5, 5 will divide 5, don't check it. So if none of the previous numbers are not dividing, the smaller numbers are not dividing, then you say that it is a prime number. Now the question is that what if somebody gives you 16 and somebody asks you to check whether the 16 is a prime or not. Now, if you follow this logic, then you will have to divide it by 2, you will have to divide it by 3, 4, 5, 6, 7, 8, up to 15. This is going to be a very lengthy calculation. You can reduce it by taking the square root of the given number. So if you take the square root of this number, so the square root of 16 is going to be 4. So you just take 16 and then start dividing it by the 4. That is 2 to 4. Whether you see if 2 is dividing, you know very well it is no longer a prime number. You are done with it. What if somebody gives you 17 and somebody asks you to check whether 17 is a prime number? Remember, take the square root of 17. You'll get 4 point something. Just take the integer value 4. So you start dividing it by 2. 2 is not dividing. Then you divide it by 3. 3 is not dividing. Good. Then take the next number 4. 4 is not dividing. That's the end of it. Don't try to divide it by 5. If 1 to 4 are not dividing, then you can simply say it is a prime number. So go up to the square root of this number, whatever number is given. Suppose if n is the number that is given to you, go up to the square root of this number, and if none of the numbers from 1 to the square root of this number are dividing the given number, then it is a prime number. If any of them is dividing, then it is no longer a prime number. However, there is a major problem with this square root. I don't know how to get the square root in the shell script. So what I'm going to do is, instead of following the square root story, I will go with the square story. What do I mean by saying that? So I know that if the number given is 16, I have to take the square root of 16 and then take it as 4. This is one way of doing it. So I will have to go from 1, 2, 3, and 4. You have to do it. So this is by, so divided by 1. See whether 1 is not 1. 1 is not there. Sorry. Divide the 16 by 2 and see whether it is dividing. Divide it by 3, see whether it is dividing, and so on and so forth. So this is the story of taking square root. Now there is the other way around. Suppose 16 is given to me. Okay. One way of checking that thing is, instead of taking the square root, you take the square of the number. So you are starting from 2, is it not? You are starting from 2. So take 2 into 2. Whether 2 into 2 is 4. 4 is less than 16. Then start dividing it. Next number is 3. 3 into 3, it is 9, which is less than 16. So go ahead. Then take the next number 4 into 4, 16 definitely. Okay. Now go up to that 4 into 4, 16. You try to divide it, whether it is dividing it. Next 5 into 5, you know very well this is 25, and the 25 itself is greater than 16. Then stop it. So that means to say that instead of taking square root, what I'm doing is I take a number, I find the square of that number and see whether the square of the number is less than the given number. So if the square of this side is less than the given number, then it is I will divide it, otherwise I will leave it. So the idea of this is, see, when you have this equal sign here, okay, if you take the square root on this side, okay, on the other side of the equal sign, you get it to this side, it becomes square. They are like the complement or inverse functions of the complement, the inverse function. So square on this side, if you want to take it to the other side, you take the square root. So that's the idea. So instead of taking the square root on the other side, I will bring it to this side and make it as a square. So slightly different logic, but this logic, I feel that it is a very simple logic. So let's go ahead and let's do that thing. So we have to continuously start dividing it until the square of this number is less than the given number. So how do I do it? For continuous division, I'm going to use the for loop. So I'm going to say for I starting from 2, so I is equal to 2, and I into I, that is I square, is less than or equal to the given number. That means square. So remember, instead of taking the, where is it gone? Instead of taking the square root on this side and then checking, I'm going to multiply it with the square and then check with the number. Okay. Then you know very well, for loop as usual, I plus plus, and just put two of them. And for any for loop, you have this do, and let us check. And the last thing, before I forget this one, I'm going to write done. Okay, so do and done in between is the for loop. And what is that we are supposed to do? You check whether the given number divides it or not. So I'm going to say if, okay, this given number, what is this given number? Let's go with the expression here. So dollar, I'm going to use because I used the double arrow, so I'm double parenthesis. I'm going to say if n by I, you know very well what is the meaning of saying n by I, so you are all familiar with that. So if this is equal to 0, if this is equal to 0, then I'm going to echo and say it is not a prime number. What do I mean by saying that is, if any number divides the given number, that means if you get the mod of that number is equal to 0, that means to say that something else is dividing. What is a prime number? 1 and itself are only dividers that you have it. Now, in this case, if something else is dividing that number cannot be a prime number. So, I'm going to say n is not a prime number, and I'm not going to use the exit option and other things. So I'm not going to use the break and the story like how you do it in C. I'm going to use the exit option. Exit with the 0. That's the end of it. If you start if, then you have to close it with the end if by typing fi. Okay. So this is what I'm doing it. I will start from 2. I start dividing the number. I will take 3 divided by number, 4 divided by number. If any of the number divides it, then it is not a prime number, and leave the program altogether. Otherwise, go till the square of this number is less than the given number. Okay. If you completed this story, that means to say that none of the number from 1 to square root of n is not dividing it. If it is not dividing, if you have not exited, remember, if it is dividing, you are exiting the program. If you still you executed this entire for loop, but still you are not able to exit this program, what does this mean? This number is a prime number. So I'm going to come out and say that echo. If you come out of this, you are going to say echo n is a prime number. Okay, done. That's it. Save it, and let's see whether I've done any mistake. If I've done a mistake, I will correct it. Otherwise, let's run and see what is it. So I'm going to use the up arrow, press enter, and enter a number 5. And what I must get, 5 is a prime number. I'm going to say enter a number 25. 25 is not a prime number. And 31, and I'm going to say 31 is a prime number, and so on. So you get the answer whether it is a prime number or not. That's all in this exercise. Thank you for your interest. We will meet again in the other exercise. Thank you.